Hi everyone, it's Miss Costa here, and in this video I'm going to be walking you through how to expand single brackets with SURDS. Okay, so here I'm being asked to expand and simplify. So what I do to do a question like this is treat it exactly as how I would treat it if it was algebra. So for instance, if I had two brackets A take B, what would I do? I'd multiply the term on the outside by each term on the inside. So that would become 2A take 2B. So I do the same thing over here. So 2 multiplied by root 8 would become 2 root 8. And 2 multiplied by negative root 2 would become 2 negative root 2. Now hopefully you've watched a video on multiplying surds, because that's great preparation for this. If not, stop, watch that if this isn't making any sense. So what can I do now? Well, this is where it gets a little bit tricky and where I need to know how to simplify surds as well. So in order to simplify a surd, they need to be in the same root. So just like with algebra, if I had 2a plus 3a plus 2a, I could simplify that because it's the same variable. So the surd needs to be the same in order for me to simplify it. So if I had, let's say, 2 root 2 plus 3 root 2, I could treat the root 2 like an algebra because it's the same value. So that would be the same as 2a plus 3a, which would be 5a. So in this case, that would be 5 root 2. So if your surd has the same value, i.e. it's both root 2 or both root 7, then you can collect it together like you would with algebra. So what I want to do, that wasn't supposed to delete, I hate it when it does that. What I want to do is simplify this so that it's in the form root 2, because that's the only way I can simplify it. So let's see what we can do here. Well, I've got root 8, and as always, to simplify a surd, I want to look for any square numbers inside of that. So any of the square numbers multiplied to make 8, yes. 4 times 2 makes 8. So I could write the square root of 8 as the square root of 4 times 2. I could then split them up, because whether they're together or apart is the same thing. Whether I write a times b or ab, it's the same thing. It's just it's under one root. So now, what is the square root of 4? I know the square root of 4 is 2, so I could just write that as 2 times the square root of 2, which would simplify to 2 root 2. So instead of root 8, I would say, because I know that root 8 is equivalent to 2 root 2. So over here, because I have two lots of root 8, I would say 2 times by 2 root 2, because that's the equivalent of root 8, take 2 root 2. So 2 times by 2 root 2, remember 2 root 2 just means two lots of root 2, so I could write it like that. So 2 times by 2 root 2 can be written like that. So hopefully you can see that would simplify to 4 root 2, because 2 times 2 is 4, 4 times root 2 is 4 root 2, and then you're taking away root 2. Okay, I'm keeping that part the same. So if I had 4a take 2a, what would that become? That would become 2a. So similarly, 4 root 2 take 2 root 2 would become 2 root 2. And that would be your final answer here. Slightly trickier because you are needing to simplify it first in order to simplify it later. Let's have a go at the next one. So over here, I've got 3 root 17 and 4 root 2. So this one should be slightly easier. Start off with a hard one. Then we're going to break it up with a slightly easier one. So 3 times by root 17. That would give me 3 root 17. And then 3 times by 4 root 2. So remember, you can do some side working to break it up for you if you like. So you've got 3 times 4 times root 2. So 3 times 4 is 12. So that would become 12 root 2. So it would become 12 root 2. Or you could have just done 3 times 4. So you could have treated it as algebra. Whichever way works best for you. So you've got 3 root 17 plus 12 root 2. Now 17 is a prime number, so you're not going to be able to find any square numbers inside of it. It doesn't simplify, and root 2 doesn't simplify either. So that is all you can do. You can only simplify the surd if a square number fits inside of it. So that's that one. Okay, now let's have a go over here where the number outside the bracket is also a surd. So we've got root 2 times by root 5. So let's think about what that would become. Well, that would become root 2 times 5, which would become root 10. So that would become root 10, and then root 2 times by root 3 would become root 2 times 3, which is root 6. So I'd have root 10 plus root 6. And 6, I cannot simplify that any further. 10, I cannot simplify that any further either. So I would just leave it as root 10 plus root 6. Now, when you're adding surds, just like with algebra, you can't combine it. When you're multiplying, you can, but when you're adding, you cannot. Unless they are like terms or like surds, then you can't. So here, that would be how you would leave your answer. Root 10 plus root 6. You can't do anything further. And here's our last question. So root 3 times by root 4. So that would become root 3 times 4, which is root 12. Now the square numbers again, 4, 9, 16. Obviously I'm excluding 1 because that won't help us at all. So I know that I can fit root 4 into that. So that is root 4 times root 3. I could also have just not done this and spotted that it was root 4. So that would be 2 root 3. Okay, so you've got 2 root 3 over here. And then you've got, different colour, root 3 times by negative 3 root 3. So that would be root 3 times by negative 3 times by root 3. So root 3 times root 3, I could write in 1 surd. So that would be 3 times 3 and then times by negative 3. So root 9 times by negative 3, which is 3 times by negative 3. And 3 times by negative 3 is negative 9. So my final answer would be 2 root 3 take 9. So hopefully you see how that worked. I split up my surd, then combine the like terms. So root 3 times root 3 would give me root 9, which is just 3. And there we go. So now let's see if you can have a go at these practice questions. So just pause the video and have a go. Okay, so how did we get on? So for the first one, we would have got 4 root 4 take 12 root 3. You're just multiplying 4 times 3. And then we've expanded it. Now we need to see if we can simplify it. So we're looking for this to see if there are any square numbers that would fit inside the surd. So we've got 4, 16, 25, 49 as our square numbers. And we know that the square root of 4 is 2. So this I would write as 4 times by 2. Take 12 root 3. Root 3 is a surd. I can't simplify it any further. So that would become 8 take 12 root 3. So hopefully that's what you got. Now for the next one, let's do the same thing. We'd multiply root 3 by 2. So that would become 2 root 3. And then we'd multiply negative 3 root 3 by root 3. So let's see what I'm multiplying here. I'm just going to write take, and then I've got root 3 times by 3 times root 3. So what's happening here, remember when you multiply a surd by itself, it just becomes itself unsurded, if that makes sense. So if I had, let's say, the square root of 25 times the square root of 25, well, I know the square root of 25 is 5. And I know that 5 times 5 is 25. So therefore, whenever a surd is multiplied by itself, it's itself unsurd. So we have 2 root 3. Where did we get to? Okay, so that means that root 3 times root 3 is just going to be 3. So that would become 2 root 3 take 3 times 3. And what's 3 times 3 is just 9. So this would become 2 root 3 take 9. And for our next question, we've got root 5 times by root 4. and 5 times 4 is 20, so that would become root 20. And then I've got root 5, so let's break this one down. Root 5 times by 3 times by root 3, so that would become root 20. Take, now what can I simplify? Well, that would become root, why have you gone big? Root 15 times by 3. Can I simplify root 15 any further? No, the only factors are 15 and 1, or 3 and 5, and they're both prime numbers, so that would become root 20, take 3 root 15. Now, I want to look at root 20 and see if I can simplify that any further. Can any square numbers fit into root 20? Yes, I could express that as 4 times 5. So I'm just writing out everything else so you can just see the linear progression. And then I could write that as root 4 times root 5, take 3 root 15. What's root 4? I know that's 2. So that will become 2 root 5, take 3 root 15. So 2 root 5, take 3 root 15. And I am showing you like all of the steps. Obviously, once you do this a fair few times, you might just be able to recognize things and do it a lot quicker. But I'm just breaking it down so you don't miss anything, especially if this is your first time doing this. Then we've got root 3 times 4, so that would become root 12. 3 times 4 is 12. And then take, so I'll put this into a little bracket again. So root 3 is being multiplied by 3 root 5. Remember, I'm just breaking this up because there's always a little invisible multiplication sign in between any algebraic terms. So that would become root 12, take, once again, well, that would actually become the same as what we just did. So that would become 3 root 15. Root 3 times root 5 would become root 15, and I bring them together. Once again, I look to see if I can simplify it. So over here, this root 12, do any square numbers fit into it? Well, 4 times 3 makes 12. 15, the only factors are 1 and 5, 15 or 3 and 5. So obviously I can't simplify that any further. I could write this as root 4 times root 3, take 3 root 15, and root 4 would simplify to 2. So that would be 2 root 3, take 3 root 15. And that would be my final answer for that. So that's how we expand single brackets. The key thing is we treat it like algebra. So it's just like expanding normal brackets. It's just we have to also multiply the surds and then simplify them. So if this is a bit confusing, then watch the video on multiplying surds and also on simplifying, because they're the little tools that you will be missing, which is why this might be a bit tricky. But hopefully this makes sense. If not, drop a comment and just let me know what doesn't, and I'll re-explain it in a different way. So thank you for watching.